Welcome to the Artificial Intelligence class. Today, what we are coming to study is called expert systems. Expert systems in artificial intelligence. The last time we studied about artificial intelligence in the automotive industry, that's in the manufacturing industry, in the car manufacturing industry. Today, we are looking at artificial intelligence in expert systems. Before we start, we'll actually ask ourselves one question. What is an expert system? In artificial intelligence, what is an expert system? So you can see from my screen, there is a diagram. You can see from my far end, I have non-expert user. And from my other far end, I have knowledge from an expert user. I have my expert system in the middle of them. We are coming to talk about this, explaining in details so that you will get to understand what entails in an expert system, what or how expert system works, and why is it that it is being classified as the most highly intelligent system in the artificial intelligence field. Before we start, do anyone has any question? Right, if there are no questions, let's begin. From what you are seeing on my screen, in fact, when we talk about an expert system, it is an interactive and reliable computer-based decision-making system which both uses facts, 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 to solve complex decision-making problems. In fact, it is an interactive and reliable computer-based decision-making system which uses facts to solve complex decision-making problems. Okay, it is considered at the highest level of human intelligence and experts. So, for example, this system is so good that it solves problem in a most complex issue or in a most complex domain. Whenever there is a huge complex so that the human mind can't get enough time to process it, these expert systems using artificial intelligence to actually solve these problems for us. Okay, you can see from my screen we have components of this expert system. Before we get to the components of this expert system, in fact, there are some important characteristics of these expert systems. One, it has the highest level of expertise. Thus, the expert system offers the highest level of expertise. It provides efficiency, accuracy, and imaginative problem solving. You, as humans, we might encounter some huge problems. For example, calculation problems, or let me say complex processor problems. The human mind can't do that. You will need a system that can mimic the human mind, but in a form of advanced level that can solve this problem. Expert system here is the best because it provides efficiency, accuracy, and imaginative problem solving. Meaning in expert system, it doesn't make mistake. When it says this, the probability that it is correct is about 95 and above percent. The next characteristics of an expert system is right on time reaction. An expert system in artificial intelligence interacts in a very reasonable period of time with the user. The total time must be less than the time taken by an expert to get the most accurate solution for the same problem. So here you ask yourself, what is an expert? When you say expert, does it mean some expert is behind this system? No, but it mimics an expert. So for example, maybe you are an expert in a certain programming language. Yes. Then you build a machine using both your knowledge. So the machine we are building, note we use both your knowledge and we combine some fact to build such system. Here you realize the system we are building or we build will become more accurate or more on time. So mostly we know that machines, they are actually on time. The machines don't get late. Yeah, because they use data and facts, gathered facts. So they use both the knowledge of an expert plus the data that has been given. So an expert system is always on time. It predicts and it's accurate and it's on time. That's on point. The next characteristic of an expert system is good reliability. In fact, an expert system in AI needs to be reliable. It must not make any mistake. An expert system doesn't make a mistake. You see, in this expert system, since we trust it so much, these systems are mostly used in a situation whereby something is very delicate. For example, we have some expert system used in a hospital. In these hospitals, maybe someone is unconscious. We have this expert system that can actually diagnose the person and predict what's happening to the person. Such system, we don't need it to be faulty or to make a mistake. Else, we are going to kill. So expert system does not make a mistake. The reliability on an expert system is so much excellent. The next characteristics of an expert system is that it is very flexible. It is vital that it remains flexible as it is processed by an expert system. Well, what do we mean by flexible? In fact, when we say something is flexible, in other words, we say dynamic, meaning it is not like defined, is not trained only in one way. So, for example, we've told our system or we programmed our system, we built a model, an expert system, in a way that can diagnose a person who is unconscious. Now, how do you define a person who is unconscious? Note there are so many ways to define that one. One, someone might be like a person who is asleep is unconscious. He or she has a point. Someone will also be like a person who is not breathing, is unconscious. We have that one today. Some people can also say, okay, someone who can actually reason well. So, meaning the person is not that a normal person. Someone can also say the person too is not conscious. In fact, your system you build has to be so flexible that you can actually define this. So you tell our system, in fact, declare someone unconscious only if one, the person is not breathing or showing any symptoms of life, or the person is asleep. Expert systems are flexible. Okay, the next characteristics of an expert system. The expert system is so effective in mechanism. An expert system must have an efficient mechanism to administer the compilation of the existing knowledge in it. In fact, for an expert system to execute or to work, note that it has been filled or it has been programmed or it has been filled with knowledge from an expert. That's why it gets the term expert system. It has the knowledge of an expert, which has been combined with data. So the knowledge we have given to the expert system, the expert system should be so effective in mechanism in such a way it can take its time to process this knowledge and execute it wherever it is needed. The last point of the characteristics of an expert system is capable of handling challenging decisions and problems. An expert system is capable of handling challenging decisions and problems. That's why we say it is an expert system, because for an expert human being, so let me say you are a doctor, you are an expert in, let me say, the nose specialist or dentist, the teeth specialist or the eye. Sometimes humans are humans. You can get distracted and you make mistake. Here, we've gotten your knowledge. Now build a model with your knowledge, add data to it, and have been given to a machine. Here, the machine is going to solely based on what it has to make predictions. So even in case it faces a very challenging situation, the machine is able to combine the knowledge from an expert and the data it has to make decisions to tackle such problems. Any question before we move on? Now, components of an expert system. On my screen, you are seeing components of an expert system. We are going to take them one by one. Okay. One, the user interface. This particular one, the user interface. What is the user interface in an expert system in artificial intelligence? The user interface, it is the most crucial part of the expert system software. This component takes the user's query in a readable form and passes it to the inference engine. After that, it displays the results to the user. In other words, it's an interface that helps the user communicate with the expert system. So watch my screen carefully. This user interface is where the input is being taken from. This user interface is where everything being entering the expert system is being taken from. So this is the place whereby the user is non-expert. This is you, the user. So the user will interact with the expert system here at the user interface. Now, what does it do? The user interface is going to take all the input sample from this non-expert user. So you are the user, you are the non-expert user. You are going to interact with this user interface to actually query or question or ask anything from this system. Then it's going to take from here and move on. Before a query or a question or request can be made to this knowledge base or engines, the user will interact with this user interface. So the user interface is actually serving as the interface whereby the user will be able to interact with the system. In fact, it is the most crucial part of an expert system software. It takes the user's request in a readable form and passes it on to the inference engine. Any question before we move on? Right. If there are no questions, let's continue. Now, the next in component you are going to target, it is the inference engine. Here, you are seeing it as the rules engine. Now we know the function of the user interface. We are moving on to the rules engine, also known as the inference engine. Now, the rules engine is the brain of the expert system. The rules or the inference engine, it is the brain of the expert system. The inference engine contains rules to solve a specific problem. It refers the knowledge from the knowledge base. It selects facts and rules to apply when trying to answer the user's query. It provides reasoning about the information in the knowledge base. It also helps in deducting the problem to find a solution. This component is also helpful for formulating conclusions. Now, this this rules engine or inference engine, this is what it does. Let's say someone just fell down. We've taken a person to an expert system to analyze and bring us, in fact, a solution. The expert system analyzes the user here using the user interface. It sends the feedback to this. This is the main engine. Now, the information from here stores here, and this engine fetches knowledge from here and add it. Then analyze it, draw patterns with it. After that, it is able to produce decision. So this rules engine is solely responsible for decision making and also for formulating conclusions. When you, the user, interact with an expert system, it takes your responses to the rules engine. Then the rules engine goes to the knowledge base, fetches some knowledge, come and add it with the information gotten from you. Try to analyze and draw patterns with it. Then finally formulate a conclusion, then give you the output. Basically, the rules engine, it is the engine or it is the core engine of an expert system. Any question here? Right, the next component is knowledge base. That's this one, knowledge base. What is a knowledge base in an expert system? What is a knowledge base in an expert system? The knowledge base is a repository of facts. When we say repository, we can also refer to a database of facts. It stores all the knowledge about the problem domain. It is like large container of knowledge which is obtained from different aspects of a specific field. Thus, we can say that the success of an expert system software mainly depends on the highly accurate and precise knowledge. When I started, I told you expert system have basically three components. That's the user interface, the rules or the inference engine, then we have the knowledge base. The user interface, this is where the user interacts with the whole expert system. So it is the crucial point, the crucial entry point of an expert system. It takes inputs or it takes queries or it takes requests from non-expert user. Now, this user interface sends this feedback response, everything, the request, the query to the rules engine. In the rules engine fetches knowledge from the knowledge base, come back to its center, try to draw pattern with the query the person asked and the knowledge it has fetched from the knowledge base. After that, it tries to draw conclusion and formulate hypothesis and send it back to the user so that the user will be comfortable with the answer. Now, the knowledge base is where all the facts or trained models are kept. So, the engines get data from the user. The engines go to the knowledge to fetch some knowledge about that particular thing and come and analyze it. So the knowledge base is like a repository or a database where all trained models, all trained knowledge acquired are being stored there. So that whenever it is needed in future, the rules engine comes there, fetches the knowledge, go and analyze with the input from the user and formulate a conclusion to make decision. Any question? Okay, let's continue. Now, who are the participants in an expert system or who can participate in an expert system? Take note, in an expert system, we have three main participants. One, we have a domain expert, that's an expert. We have knowledge engineer when we have the end user. I'll go over again. In an expert system, we have three main participants. One, we have a domain expert, we have a knowledge engineer, then we have an end user. Now, what is a domain expert? In fact, he is a person or group whose experts and knowledge is taken to develop an expert system. Take note, the diagram you are seeing on my screen, at the far end here, we have a knowledge base. This knowledge database wasn't generated by the system. Take note. It is we, the system developers, that stored this knowledge. Now, where did we get this knowledge? We got this knowledge from an expert here. So this is the expert. So knowledge from an expert. So we want to build an expert system. Let me say a medical expert system. We will go and see a doctor or someone expert in any of the medical fields. So let me say dentist. Then we get knowledge from the dentist. we bring this knowledge and store it in the knowledge database. Here, the expert has done his part. So the knowledge we store in the knowledge database is from the expert. Okay, the next person here is knowledge engineer. Knowledge engineer is a technical person who integrates knowledge into computer systems. Now, we sort out knowledge from an expert. So we are building a medical expert system, maybe to detect diseases in the diseases among the teeth. We went to a dentist. Then we asked the dentist, how can we detect, or what shows if a person is having let me say a disease concerning the teeth or something. So then the expert, that the dentist, will tell us, oh, when you see this, when you see that, when you bring this, when you bring that, we will gather all this knowledge, come and store it in a database called knowledge database. Okay, here the expert has done his part. Now, who built the knowledge database and connected it to the rules and connected it to the user interface? This is the knowledge engineer, the person connecting these three models. The knowledge, the engine, and the user interface is called the knowledge engineer. He is the technical person who connected these three components together to actually make the expert system possible to come into existence. Any question? Now, an end user. It is a person or group of people who are using the expert system to get advice which will not be provided by the experts. Let's say we are building an expert system. So expert system concerning dentists, any disease that comes with the teeth. We got our knowledge from a dentist. We compiled the knowledge in a knowledge base. We found an engineer to integrate all these three, the engine, the interface, and the database. Now, we who are going to use the system are called the non-expert user or the end user. So me as an end user, I'll go to this system and I'll say, okay, sometimes I'll be there and my teeth will be aching me. I'll just tell the system. The system will take this feedback or this input from the user from here, the user interface. It will send it to the engine. The engine will scan through the database or the knowledge base, fetches something which can actually draw patterns, bring it here, try to draw patterns and actually formulate conclusion, then give it out, give the advice out to the user. A very simple system. The user will interact with the user interface. The user interface will push this data to the knowledge, to the engine. The engine fetches knowledge from the knowledge base. It brings it back to the engine. It analyzes everything, then formulate conclusion, then sends the feedback or the advice to the non-expert user or the end user. So I'll describe my disease to a machine. Then within some few seconds, the machine will tell me, oh, this and this is affecting your teeth. Go to the drugstore and buy this medicine. This is an expert system. Any question? Right, let's continue. The process of building an expert system. How can we build an expert system? As artificial intelligence students, how can we build, since we understand how expert system works, how can we build our own expert systems? Ladies and gentlemen, we have 2 minutes to end this session. When it ends, I'll generate a new link. Quickly join it and let's continue. Our next topic is how we can build an expert system as an artificial intelligence student, since we know how expert system works. Okay, 1.1. Please, I hope what you are doing, you are jotting down things. The knowledge you are taking here, should you go somewhere and you want to apply, you will be asked to actually demonstrate something. You should be able to say something that can not only show him maybe your intention report or your certificate. You should actually demonstrate your understanding of artificial intelligence. We hope you are jotting down some things. The process of building an expert system. We will rejoin again. I'll end the session now. We will rejoin again. Then we will start from there.